Find the area of the shaded region. Right, so we're looking for a probability, a shaded region under the normal bell curve. The graph to the right depicts IQ scores of adults. Those IQ scores are normally distributed, hence the bell shape, with a mean of 100. Okay, so this is not standard, so we don't have z-score boundaries here. A mean of 100, standard deviation of 15. Right, so just as a quick recap, standard normal has a mean of 0, standard deviation of 1, and z-score boundaries. A non-standard normal has a mean that is not 0 and or a standard deviation that is not 1, and we have x values rather than z-scores. Okay, so the boundaries of a standard normal are z-scores. That would be like these vertical boundary lines that split up the area under the bell shape into regions. And for non-standard, they would be what we call x values, because they would represent our random variable that's being recorded in units that have a mean other than 0 and or a standard deviation other than 1. Like this example here, because our x values are IQ scores, which are normally distributed with a mean of 100 and a standard deviation of 15. So not standard. All right, so in order to use the z-score table, we would have to convert the scale to z-score. So this is an x scale with a mean of 100 in the middle there, standard deviation of 15, right? And so if we wanted to see how the z-scores would line up, we can do that. We can turn this 88, well, let me remind you of the formula. The z-scores are x minus the mean divided by the standard deviation, because we're actually trying to find out how many standard deviations will fit into the distance between x and its average, the center. And because you're subtracting the mean from x, if x is larger than the mean, you'll get a positive z-score, which means that x values that are greater than the mean will have a positive z-score and be over here on the right. X scores that are less than the mean will end up having a negative z-score over here on the left. So for this one, our x value is an IQ score of 88. Okay, that's our x. And the mean is 100. Standard deviation is 15. So the difference there is 12, negative 12 over 15, and 3 goes into those evenly. So we have 4/5, which is negative 0.80. So that's a z-score, right? Now notice that it's negative, and notice that it's just not quite 1 standard deviation down. So that seems reasonable. Just looking at the location of my IQ score, it does look like it could have a z-score of negative 0.8. It does look like it could be just, less than an entire standard deviation down. And it is, because if you do 100 minus 15, you'll get 85. So a full standard deviation jump down will put you at 85. So it makes sense that 88 is above a z-score of negative 1. It's greater. It has a z-score greater than negative 1. All right, so now we can use the z-score table. Now that we have a z-score, we would look in the z-score table, which I'll take you over there now. And we're going to look at 0.80. So here you see negative 0.8 right here on the left. Hope you can see my little cursor there. And I'm going to stay in the first column because my last digit is a 0, and you can see up at the top here, this column is for z-scores that have the last digit 0. Go back down. All right, so the area to the left of that boundary is 0.2119. So that's this region right here, has an area, so that's my left area of, I talked too much and I forgot what the answer was. Let's see. Negative, 0.2119. So 0.2119. And what I'm looking for, though, is the blue region, the aqua blue region here. So to get that, I'm going to do 1 minus 0.2119, and that will give me 0.7881. So the final answer is 0.7881, rounded to 4 decimal places as needed. Okay. The other way that you can check your answer here, and I say check your answer because I'll ask you for at least one problem. I'll be wanting you to be able to show me that you know how to convert to a z-score so you can use the z-score table. But we do have the ability to check our answer using the normal dot distribution. So in Excel, to check my answer with a z-score, I'd say the probability that z is less than negative 0.8. I can find that doing norm dot distribution with a boundary of negative 0.8, mean of 0 because I'm talking about a z-score, standard deviation of 1, and 1 for cumulative. So that is actually going to give me the same answer I got out of my table. I can also check it with the x boundary, which is 88, with norm dot distribution and the x value 88, mean of 100, standard deviation of 15, and 1 for cumulative. Now I'm going to go over to Excel and get these answers and show you how sometimes they'll be exactly the same or almost exactly the same, and sometimes the z-score one will be a little different than the one found using technology, because the one found using technology doesn't have round off error. The z-score table tends to have round off error in it, but we already see that the answer is supposed to be this when it's rounded to 4, including any round off error that there might be as a result of using rounded values in a table. This will give us a more accurate answer. This will give me the same answer most likely, but they could be slightly different. This one is more than likely going to be pretty much the same exactly as that one, whereas this one could be off different a little bit more. Okay, so let me calculate that and come back. All right, so both of them gave me perfectly the same answer as the one I already have from the table. Right, so it's really, if you were able to figure out how to find areas related to z-scores, this is just one more layer to that. As you can see, converting between x values and z-scores is one skill that you want to be able to show for the test. And you also want to be able to show how to check your answers, verify using Excel. And I would like to have you either write out what you did on paper, or I can look at what you did in your Excel spreadsheet if you submit one, which is the easier way to do things. But that's it for now. I'll see you on the next one.